Humans have more than 5 senses. For generations, we've taught that humans perceive the world through 5 basic senses. But researchers now recognize a far more complex sensory landscape. Beyond sight, sound, touch, taste, and smell, the body relies on additional systems to navigate and interpret the environment. These include balance, spatial awareness, temperature detection, internal pressure monitoring, and even subtle magnetic orientation. Together, they expand our understanding of human perception from a simple model to a dynamic network of specialized abilities. These senses work continuously, often without conscious awareness, providing a richer and more adaptive picture of how we interact with the world. The human sensory system is not limited. It is layered, diverse, and still being fully understood.
The body as a field of receptors. Across the entire surface of the human body, trillions of microscopic receptors are constantly collecting information. These receptors detect changes in temperature, vibration, airflow, moisture, chemical composition, and even faint electromagnetic shifts. Each one is part of a vast biological communication network, sending signals to the nervous system in real time. Much of this activity remains unnoticed at the conscious level, but it influences posture, movement, instinctive reactions, and emotional tone. In this sense, the body functions less like a collection of organs and more like an integrated sensory array. It is a continuous receiver, always sampling the environment, processing data, and supporting decisions long before the mind becomes aware of what triggered them. The pineal gland as an internal sensor. Nestled deep within the brain, the pineal gland is historically associated with regulating sleep and circadian rhythms, but modern scientific research reveals that it may play a broader role. The gland is sensitive to light patterns, electromagnetic fields, and natural cycles in the surrounding environment. It reacts to changes in day length, weather patterns, and even geomagnetic fluctuations generated by the sun and earth. These subtle cues are integrated into the brain's regulatory systems, influencing mood, alertness, and physiological timing. Though small in size, the pineal gland acts as an internal sensor, helping synchronize the body with external rhythms. Its reach suggests that our perception of the world includes layers of information far more nuanced than previously understood.
Before his work at SRI made headlines, Ingo Swann had already built an unusual scientific resume through a series of experiments in New York. His early involvement began in Cleve Baxter's laboratory, where Baxter's pioneering studies with plant communication opened the door to controlled tests of intention. Swann participated in experiments influencing plants, metals, and even sealed canisters of gases, famously triggering a dramatic response from a plant simply by imagining harm. In Gertrude Schmeidler's lab, he attempted to raise or lower the temperature of hidden thermistors, producing small but repeatable effects, a breakthrough in a field long criticized for lacking reproducibility. These results drew national attention from outlets like Smithsonian and Time magazine. At the American Society for Psychical Research, Swann expanded into perception studies, attempting out-of-body identification of targets suspended 15 feet above him, working with rotating color wheels, brightness comparison machines, weather perception tests, and early outbound trials in which he described distant locations he had never seen. By the end of 1971, he had completed an astonishing 200,000 experimental trials, and by the mid-1970s, his total work would exceed 500,000. These early efforts formed the foundation for what would later become known as remote viewing.
Ingo Swann and the ASPR experiments. Before Ingo Swann became known as the father of remote viewing, he was inside a New York townhouse running hundreds of thousands of perception experiments at the American Society for Psychical Research. These weren't simple tests. They pushed the limits of what human perception could do. One of the most famous was the out-of-body experiment. A target was placed 15 feet above him, out of sight, while he was wired to EEG equipment. Swann would sit calmly, try to float upward, and report what he saw. In one session, he assumed he completely failed, until the researchers flipped his drawing upside down. Suddenly it matched the target perfectly, suggesting he wasn't guessing before it reached conscious awareness. But that was only the beginning. Swann tackled brightness comparison tests, boxes with rotating color wheels, distant weather perception, and what would become the first outbound experiments. Someone traveled to a secret location, and Swann described it from miles away. By the end of 1971, he had completed over 200,000 trials, a staggering amount of data. Later at SRI, that number would rise to 500,000. These results built his reputation worldwide, and eventually caught the attention of intelligence agencies like the CIA and DIA. Swann became both famous and, for a time, completely classified. A man known publicly for extraordinary perception, and privately for work the government didn't want to talk about.
Ingo Swann argued that remote viewing shouldn't be understood through parapsychology alone, but through modern science. He pointed to emerging fields: neurobiology, electrophysiology, brainwave research, sensory coding, biomagnetic navigation, and subliminal perception, all revealing subtle layers of human sensing far beyond the traditional five senses. He connected this modern picture to ancient knowledge, noting that practices described in Patanjali's Yoga Sutras, such as butchery, distant seeing, and other siddhis, mirror what we now call remote viewing. These traditions taught that you don't train the ability directly, you train the mind systems that produce it. Swann emphasized research showing humans may have 17 or more sensory channels, from electromagnetic and directional receptors to pineal gland photoreception. We receive millions of bits of information every second, yet consciousness processes only a tiny fraction. According to Swann, remote viewing arises from this non-conscious layer. He explained that all perception is an internal simulation, filtered through the cortex, the bottleneck of awareness. Training remote viewing, he said, is really about training the cortex to admit more information, much like the ancient systems described by Patanjali. Swann ended by promising to continue the discussion in his next session.